I'm going to show you how to use right-angled trigonometry to find a missing side in a right-angled triangle. There's going to be quite a few examples here, so fast forward through ones you don't feel are necessary for you to look at. So first thing that we need to do is label these sides according to this angle. Now, this side here, 5 centimetres, that is opposite the angle that I've just coloured, so we call that the opposite side, and this side here is the hypotenuse. So we have labelled the hypotenuse and we have labelled the opposite. This side here doesn't have any information, so we don't label that one. So when it's opposite and hypotenuse, we use sine. So we know that sine of the angle, so sine is equal to the opposite divided by the hypotenuse. This formula triangle is to help people that find it a little bit more difficult to rearrange. So the thing that we're trying to find is x, which is the hypotenuse. So we cover up the hypotenuse in the formula triangle and we write out that hypotenuse is equal to the opposite side divided by sine of the angle. Now we refer back to our triangle. The opposite side is 5 centimetres. The hypotenuse is x, divided by sine of the angle, which is 35, so sine of 35 degrees. Put that into the calculator, gives you an answer of 8.7172333978. You might have to round this to 1 decimal place in the question, in which case your answer would be 8.7. Or you might have to round it to 3 significant figures, in which case your answer would be 8.72. So another example, again, we need to label the sides that we've got in relation to this angle here. This side here is the hypotenuse, and this side here is next door to this angle. It shares a side with this angle, so that side is called the adjacent. So this side here isn't labelled, so we don't label it with anything else. So we've got the adjacent and the hypotenuse, which means that we're going to use cosine. So we've got cosine of the angle is equal to the adjacent divided by the hypotenuse. Using the formula triangle again, we need to find the adjacent side. That's the thing that we don't know. So we're covering up the adjacent side, and we write out that the adjacent is equal to cosine of the angle, and then next to each other, so times by the hypotenuse. So if we look over at our triangle again, the adjacent is x, and then we've got cosine, the angle is 27, times by the hypotenuse, which is 14. Put that into a calculator, gives you an answer of 12.474091334. If you rounded that to 1 decimal place, because that's what the question asked you to do, you would get 12.5. If you rounded it to 3 significant figures, you would also get 12.5. So either way, you get the same answer depending on the rounding there. Another question, so same idea. There's our angle. We label the sides according to that angle. This side here is opposite, this side here is adjacent. In that situation, we use tan. So using the formula triangle again, tan of the angle equals the opposite side divided by the adjacent side. Adjacent's the one that we don't know, so we cover that up within the formula triangle, and therefore write down that the adjacent is equal to the opposite side divided by tan of the angle. The adjacent side is x, so we write x is equal to the opposite side, which is 11.2, divided by tan of the angle, which is 43. Put that into a calculator, gives us an answer of 12.010529555. If we had to round that to 1 decimal place, then we would write 12.0. If we had to round that to 3 significant figures, we would also write 12.0. Okay, another example. Same idea, here's our angle. We need to label the sides in relation to that. So this side here is the hypotenuse, and this side here is the adjacent because it's next door to the angle. So we've got adjacent, hypotenuse labeled, so we're going to use cosine. So cosine of the angle is equal to the adjacent divided by the hypotenuse. The thing we're trying to find is the hypotenuse, so we scrub that out, cover that up on the formula triangle, and we write down the hypotenuse is equal to the adjacent side divided by cosine of the angle. The hypotenuse is x, so we fill that in, is equal to the adjacent side, which is 3.5, divided by cosine of 65, because that's the angle. Put that into a calculator, and that gives us an answer of 8.2817055541. Rounding that to one decimal place would give us an answer of 8.3. Rounding that to three significant figures would give us an answer of 8.28. Okay, next example, same idea. There's our angle. This side is the hypotenuse. This side here is opposite. So we're going to be using sine in this example. Sine of the angle is the opposite divided by the hypotenuse. The thing we're trying to find this time is the opposite. So we cross that part out and write down that opposite is equal to sine of the angle times by the hypotenuse. The opposite side here is x. The angle is 36, so we write sine of 36 times by the hypotenuse, which is 10. Put that into a calculator, gives us an answer of 5.87, 7852523. Rounding that to one decimal place would give us an answer of 5.9. Rounding that to three significant figures would give us an answer of 5.88. Okay, this is the last example. We've got, here's our angle. This side here is adjacent to that angle. This side here is opposite to that angle. So we've got opposite and adjacent. We're going to use tan. So tan of the angle equals opposite divided by adjacent. In this question, we're trying to find the opposite. So cover that up in the formula triangle. Opposite is equal to tan of the angle times by the adjacent side. So if we look at the triangle, we've got the opposite side is x, and then we've got tan of the angle, which is 40, times by the adjacent side, which is 4. Put that into the calculator, gives us an answer of 3.356398525. If we round that to one decimal place, we would get 3.4. If we round that to three significant figures, we would get an answer of 3.36. Okay, several examples there of showing you how to find a missing side in a right-angled triangle using right-angled trigonometry.